What is the slope of the curve y equals 3x cubed at point x comma y? Okay, we'll remember that from lesson 3 we actually did want to know what is the slope of the curve y equals 3x cubed at some arbitrary point. I don't remember what that point was, and it doesn't matter at the moment. And we said in lesson 3, wouldn't it be good if we could come up with a function g of x where we could plug x in and that would give us the slope of function f of x. Oh dear, I better change that because that looks like I'm saying slope off, which somebody might think of as an insult of some sort. Okay, so g of x is the slope of f of x at point x. That's basically what we're talking about. So our f of x is equal to 3x cubed, and then g of x will be the slope at point x. Okay, I think for this I am going to go back to the y equals notation. So I'm going to say y equals 3x cubed. I'm going to use both notations interchangeably because it gets used to it. It gets you used to it, and it's easier for me to think in one sometimes than the other. Okay, so y equals 3x cubed, and we want to know what the slope is. Okay, so we remember our slope is delta y by delta x. And we said if we can get 2 points that are really close together, we can approximate a tangent line using a secant line going through 2 points that are so close together that they might as well be 1 point. Let's use another piece of notation here. For delta x, I want to say a little tiny bit of x, not just a change in x, but a teeny weeny itty bitty little tiny change in x, like an infinitesimally small change in x. I want to use the lowercase delta. So that basically delta x is a teeny itty bitty little tiny bit of x. So our change in x, or our delta x, would actually be x plus delta x minus, let's just say x. We're going to draw our secant line from x to x plus delta x, where delta x is the teeniest little sliver of x. And our change in y is, so it's y plus a little tiny itty little bit of y, and then that's going to be minus y. So that's what we're looking at. Well, that's not going to be easy to process, so let's express y in terms of x. So y is 3x cubed, so this is 3 times x cubed, but we're not using x, we're using x plus delta x, because this is our y. So 3, and we're looking for the change, so it's 3 plus delta x cubed minus 3x cubed. And that's our change in y. Our change in y is 3 times the little bit bigger x cubed minus 3 times x cubed. Okay, well, first of all, we can cancel that x and that x. X plus delta x minus x, well, x minus x is 0, and 0 plus anything is itself, so that bit's simple. So now we need to expand out this 3x cubed bit. So first of all, let's expand that out, just for those who might not know. So let's do it as a plus b cubed is equal to a plus b times a plus b times a plus b, which is equal to, so let's do the first two brackets first. So that's a times a, actually let's just expand it out, so that's just a into a plus b plus b into a plus b, and then of course the whole thing is multiplied by a plus b. And that's equal to, well, a times a is a squared, a times b is ab, and then b times a is ba, which is the same as ab. So ab plus ab is 2 times ab. And then b times b is b squared. That's 2. And then all that is multiplied by a plus b. And then that's equal to, and then again we can distribute that out, so that's a squared times a plus 2ab times a plus b squared times a plus a squared times b plus, that's not a good plus, plus, now where was I? Oh yes, a squared times b, so it's 2ab times b, 2ab times b plus b squared times b. And then simplify that. So a squared times a is a cubed. 2aba is 2a squared b, and so that's 2a squared b, and this is a squared b, so 2a squared b plus a squared b is 3a squared b plus, and then we've got b squared a plus 2abb, well abb is ab squared, so that's b squared times a plus 2 times a times b squared, and b squared times a is the same, a times b squared is the same as b squared times a, so b squared times a plus 2 times b squared times a, would equal to 3b squared times a. So that's 3, I'm just going to say a b squared. And then b squared times b is b cubed. And that is our expanded out form of a plus b cubed. And so now if we change a for x and b for delta x, we have our term here is 3 into, so we've got x plus delta x cubed. So whenever we see a, we say x, and whenever we see b, we say delta x. So this is x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. And then that has to be minus 3x squared x cubed. And let's move this over so that it looks a little bit neater, otherwise we might get confused. I'm going to put a line there so that we know that that's separate. And all this, I should have kept my line, all this is divided by delta x. And you know what, I forgot something important. This delta y by delta x, we want the slope of the tangent line, not the secant line. So we really want this to be the limit. We just looked at limits in lesson 4. The limit as delta x approaches 0. So that's really what we're looking for. So I really should write the limit in here, because we know when delta x is 0 we're going to get something divided by 0 error. So we really want to find the limit as delta x approaches 0. There we go. Okay, so let's expand out these brackets. So we're looking for the limit as delta x approaches 0. And I'm actually going to write that under the limit because it gives me some more space. And I'm going to try and remember all of this is that we're trying to find the slope. So 3 times x cubed is 3x cubed plus 3 times 3x squared delta x will be 9x squared delta x plus 3 times 3x delta x squared would be 9x delta x squared plus 3 times delta x cubed, as 3 times delta x cubed is equal to 3 times delta x cubed. Delta x cubed. So that's 3 times everything in that brackets, and then this whole thing has to be minus 3x cubed, because that's this term here. And then all of that is divided by delta x, which, as remember, is an itty bitty titty bitty little tiny bit of x. Okay. Right then, so I think the first thing we can do, we can take this 3x cubed here and cancel that with this minus 3x cubed here. And then we can divide everything by delta x, because we remember delta x is not 0, but it's the limit as delta x approaches 0. So we can get rid of that delta x there, and that delta x squared will just become normal delta x, and that delta x cubed will become delta x squared. So we can say the slope is equal to the limit as delta x approaches 0 of 9x squared plus 9x delta x plus 3 delta x squared. Now, as delta x gets closer and closer and closer and closer and closer to 0, so these terms will get closer and closer and closer and closer to 0, because anything times 0 is 0. So if you multiply something by a very, 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 very tiny number, then you've got a very, very, very tiny bit of that thing, which is a very, 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 very tiny number. So these terms become less and less significant to the point where they're so very small that they're not even worth considering, which means we can say that the slope it's not a very good P is equal to 9x squared, because all the other terms get infinitesimally close to 0 to the point where we just don't need to consider them anymore. So what is the slope of the curve y equals 3x cubed at point x comma y? Well, the answer is 9x squared. So our g of x such that f of x is 3x cubed, g of x will give us the slope. Our g of x would be 9x squared. And I want to introduce you to two more terms. Calculus was invented by two people simultaneously, and credit was given to those two people. And because of that, two different sets of terminology tend to be used somewhat interchangeably. So the slope of the curve at a certain point is called the derivative. And if we use the y equals something, we say the derivative is dy by, and then d and whatever the something is. So if y is some function of x, if y changes as a result of x, then we write dy by dx. So let's say y equals 3x cubed. Then we say the derivative is dy by dx, which is equal to 9x squared. That's the derivative. If we said f of x is equal to 3x cubed, we would write the derivative as f prime of x is equal to 9x squared. There's just different ways of writing the derivative. And why do we use two different ways of writing the derivative? Because calculus was invented by two different people and they were both given the credit. Okay, And that is enough for this lesson. If you have got this far and you now know that the derivative of y equals 3x cubed is dy by dx is equal to 9x squared, you can go back to the question at the end of lesson 3 and you can plug the new value for x in and you can get the slope of the curve, and you can check if the estimated slope that you got was anywhere near the actual slope. But now we have a way of determining the slope for any given point in x for any particular function of x. Okay, in the next lesson I want to introduce you to a couple of new concepts before we work our way towards getting a way of finding the derivative of any polynomial. Okay, hope that was helpful, and I'll see you in the next lesson.